All right, so let's get started with section 10.3, which is all about double angle and half angle formulas. I have, again, in our notes, provided you with those information. So here's the 10.3. These are the two main ones that we're going to deal with. Now, in section 10.3, they do give us some other ones called the product to sum identities and sum to product identities. These are okay. We're not really going to use these all that much. Actually, probably like never. So, but I did put them out here in the notes for you if you wanted them. Again, product to sum identities, sum to product identities. We're not really going to touch these, just so you know. We really wanted to make sure that we understand the double number identities and the half number identities. Now notice for some of these, especially when it comes to the cosine double angle, there are quite a few different formulas for it. Okay, there are 3. So sometimes when one of these formulas might not work, you try looking for the other one. Sine double angle only has 1, and tangent double angle only has 1. And then down here, you can see that the tangent half angle has 3 different possibilities. So keep that in mind when you guys are looking at these. Just because you might not see that this will work for one of them, we could use it for maybe try another one, where one that just has sine and one that just has cosine, things like that. Okay, so hopefully you got this handy. I also got your trig chart handy. Okay, and the big thing is they're going to want you to use these formulas forwards and backwards, just like what you experienced in the sum and difference trigonometry identities. Okay, so let's get started. So the first thing you're going to run into is they're going to say, hey, here's what cosine equals. And they're going to tell you that sine is less than 0, which means that sine should be negative. And they want you to find the cosine double angle and the sine double angle. Okay? Well, if we look at these formulas, all I know is cosine right now. Obviously, for the cosine double angle, we don't want to use this because it's got cosine and sine. All I know is cosine. I don't want to use this one because all I got is 1, or all I got is sine squared here to help me figure out the cosine double angle. But if you look right here, this is why there's 3 different formulas. Right here, this one is just about cosine. And all I need to do is take 2 times cosine squared minus 1. So let's use that. So we can figure this guy out real quick by using 2 times cosine squared theta minus 1. Well, we know what cosine is. So this is 2 times 84 over 85 squared minus 1. So you just got to do a little bit of work. Go to your calculator and let it do the heavy lifting for you. Okay? There's no reason why you should be multiplying all that by hand. So let me eventually get to my calculator. Here it is. Same kind of calculator that you have. And you can also do, if you got your handheld, I could have easily done this with the handheld, but I'm just going to go ahead and show you putting it all into the calculator, because I can put it into the calculator the same way that you see it right here. I can put this whole thing in and just let the calculator kick it out. Okay? Weird. My calculator's doing funny things. Let's see if I can fix that. There we go. So 2 parenthesis alpha y equals 84 over 80, not 88, silly Mr. Armstrong, 85. Scroll out to the side, square that, and then minus 1. Same way that you see it on my paper. And there it is. There's what the cosine double angle formula looks like. And that's what they want. So 6,887. So this is equal to 6,887 all over 7,225. Okay. See a lot of kind of like plug and chug in this. Now, let's talk about sine. So up here, we know that sine must be negative. Okay? In order to figure out the sine double angle, if you go back to your formulas, there's only one formula, and it's 2 times sine cosine. So we actually have to figure out what sine is. Now you got a couple of ways that you can do that. Right here, you already know what cosine double angle is. So you could plug in that 6,000 over 7,000 fraction here and solve for sine. Or if you remember, we have a trig identity. Okay, let me zoom in on this. We have a trig identity that says sine squared plus cosine squared equals 1. There's that Pythagorean theorem trig identity. So we know what cosine is. So let's just solve for sine squared. Okay, so this is 84 over 85 squared equal to 1. So really, sine squared is going to be equal to 1 minus 84 over 85 squared. So let's figure out what that fraction is. Okay? So we come right in here. 1 minus parenthesis alpha y equals 84 over 85. Scroll out to the side, and that is squared. Now, so we got 169 over 7/25. Now remember, oh gosh, it's getting slow because I have a lot of information on this page. I'm lagging. Okay, but remember this is sine squared. So how do I get rid of something squared? You square root it. But remember, when you square root both sides, it's really plus or minus. And that's why they gave us this information up here about sine. Excuse me. So we really don't have to worry about the plus or minus down there because we already know that sine should be negative. But technically, when we do this, it should say sine equals plus or minus. But again, we already know that sine should be the negative version because of what it told us in the directions. So you just go to your calculator and let it do the talking. Second x squared. And then you could either put the fraction in or go up and grab it. And there you go. And hit enter. And there's our fraction. 13 over 85. So negative. Gosh, doesn't want to work today. 13 over 85. And now you have sine. So we can run our formula for sine squared. Or sorry, not sine squared. Sine double angle. So the sine double angle is 2 times sine times cosine. So we're going to take 2 times sine theta times cosine theta. So that'll be 2 times negative 13 over 85 times 84 over 85. Okay? There you go. And then you just go to your handy dandy calculator and you start doing some multiplying. 2 parenthesis alpha y equals negative 13 over 85. Scroll out to the side, open up another parenthesis, alpha y equals 84 over 85. Scroll out to the side, close it. And there's our answer. Negative 2,184 over 7,225. So negative 2,184. 184 over 7,225. And there you go. See, nothing crazy, just a little plug and chug. But don't forget some of those identities that we learned all the way back and 10-1. These come involved. Or some other things you could have done, going back to chapter 9 in 9.5. So we know that sine is negative, and remember that this is x over r. Sine is y over r. So you already know what the r is. You already know what the x is. You could find the y value and use what you learned back in 9.5 to figure out what sine is. Okay? Didn't necessarily have to do sine squared plus cosine squared equals 1. Lots of ways to do this because you have lots of information about trig now. All right, so it says use the double angle formula to find the exact value. So right now, if you go out to your notes and look at our chart, we don't have an angle 105. Okay, we don't. See, it's not there. But they've given us a hint. They said use a double angle. So let's look at this. It says 2 cosine squared minus 1. So let's go back out here and let's look for that idea. Do you see a 2 cosine squared minus 1? Yes, it's right here. We used it in the previous one. So they want you working backwards, just like what happened in the sum and differences. Sometimes we work forward, sometimes we work backwards. Go ahead, pause the video, and work this backwards. You're going to turn this into cosine double angle and solve. Go. Okay, so we know that this is equal to cosine 2a. This guy's a. So all we have to do is say cosine 2 times 105 degrees, which is cosine 210. Now that is on our chart. So you just go out to your chart, cosine 210. So here it is. The answer is negative square root of 3 over 2. And that's all they want. That is the exact value. Nothing crazy. Sometimes you're using them straightforward. Sometimes you're going backwards. Okay? All right. Go ahead, pause the video, see what you can do on this one. Okay, so it says simplify the expression, which means that we either want this to come out to a constant or we want it to come out to a single trig function or maybe a single trig function with a power. Remember, that's what simplify means. So if you look at this, obviously it's giving you a clue. They want you to look at tangent, okay? So if we come over here, right here is what you have, okay? They're wanting you to look at the double angle of tangent. So let's write down what we know about tangent double angle. Tangent double angle is equal to 2 tangent A all over 1 minus tangent squared A. Let me double check that. Yeah, 2 tangent A over 1 minus tangent squared A. Okay. Now, notice that this guy up here is missing the 2. I mean, this is really, really close to the double angle for tangent, but I'm missing a 2 up here. See, there's a 2 there, but I'm missing it up here. So remember how I say that we can affect things by multiplying them by 1. So if this guy is missing a 2 up here, what else needs a 2? The bottom, right? So that's like multiplying by a 2 over an extra 2 down here. See, 2 over 2 is just 1, right? So we're multiplying by 1. And now you forced in what you need to happen. Sometimes you have to force in things that you want to happen to make sure that the formula happens, okay? Or another way to think about this is if I'm going to put a 2 in the top, what can I multiply the 2 by to cancel it out? a half, because a half times 2 is 1. That's another way to think about this. Instead of just multiplying the top by 2 and the bottom by 2, think about it as you multiply the top by 2, and then you multiply all this by a half, which takes out that 2 that's right there. Okay? Because I had to get a 2 up here so that I can transform all of this into the tangent double angle. So what you're looking at then is everything inside my parenthesis here becomes tangent to A. Anything that was not inside my parenthesis just gets put in front of it. So that 1/2 right there is right here. So what they did was, in order to get this guy, this expression right here, is we took a half times the tangent double angle. That's where this black expression comes from. Because if I take a half times that, the 2's are going to cancel each other out, guaranteed. Okay? And so now, you know what A is. This guy's A. It should have been green. This guy is your A. So all we're going to do is say that we've got 1/2 tangent 2 times 23 degrees, which is just 1/2 tangent 46 degrees. And that's what they're looking for. That is the simplified answer. Because tangent 46 is not on our chart. Okay? They're looking for a simplified answer, and notice that this is a single trig function. That's what they want. Okay? So sometimes when you're working these, sometimes you have to multiply by 1, which is what I did here. A half times 2 is really just 1. Okay? So sometimes you have to manipulate it to get what you want so that you can exchange. Or in other words, substitute. Try it again. Try this one. Go. All right. If you notice, this looks like, in the double angle formula, sine double angle. Okay? It's 2 times sine times cosine, right? So let's write this down. How did I write it down before? Okay, I did it in black. So sine double angle A is equal to 2 sine A cosine A. But all of a sudden we got this 20 in front. So what really happened here? Well, how do I turn this 2 into the 20? You bet. What they did was they took 10 times 2 sine A cosine A. See, just a little manipulation they did on their part. Because 10 times 2 is 20. And now, this part, 2 sine A cosine A, matches 2 sine cosine A, and we can exchange. So in the end, this is what you're really looking at. 10 times sine 2A. And you know what A is? A is the 15. Okay? So now, if we plug in, we have 10 times sine of 2 times 15 degrees, of course. Well, that gives us 10 sine 30 degrees. But we know what 30 degrees is. Okay? So this time they actually want you to figure it out. Where before, we didn't know what tangent 46 was, so that's why we stopped. But now we know what sine of 30 degrees is. Sine of 30 degrees is a half. So all they want to know is what is 10 times a half, which the answer is eventually 5. So if you have a trig function that you can figure out, one that exists on our chart, you need to do it. See? Sine 30 degrees a half. All right. Moving on. So the next one says, okay, so now we're going to start doing half angles. And yes, I know sine pi over 2 is on our chart, but they actually want you to do the half angle for this. So pretend like your angle A is right there, that it's just pi. Okay, so they really want you to take and perform the half angle. But I know that sine pi over 2 is out on our chart. We can figure that out. But appease the math gods and do the half angle. Okay, so if we go to our notes, you're just running this straightforward. Here's your half angle formula. You need to run it. Okay, so go ahead, pause the video, give it a shot. Go. All right. So, half angle. So, sine of A over 2 equals, we go with plus or minus, okay, square root of, sorry, I forgot the formula, 1 minus cosine A all over 2. 1 minus cosine A all over 2. Okay? All right. So, our A value is pi. So what you're looking at then is plus or minus square root of 1 minus cosine pi all over 2. So we know what cosine pi is. That's 180 degrees. So if you come up here and look, here's 180, there's the pi. So we need cosine of pi, which is negative 1. All right, perfect. So we're going to have plus or minus the square root of 1 minus, I believe we said it was a negative 1. Yeah, negative 1 divided by 2. Okay? A negative by a negative is a positive, so that gives you plus or minus square root of 2 over 2, which is the plus or minus of the square root of 1, which is plus or minus 1. But again, we already know what kind of answer this should be because it's pi over 2. So that means this answer should be the positive version of that. So in the end, you want the positive 1. Okay, I'm going to talk more about your signs here in a second. But in this one, because we knew what the answer was, we know that it should be the positive version. Okay. Also, the reason why we know this information is because pi over 2 is a quadrantal angle. It's on the y-axis, the positive side. So usually when you're looking at the signs of these, you need to look at what is the sign of your half angle, okay? Or what quadrant is your half angle in? Of the, that's a horrible the. half angle. So our half angle is pi over 2. That's quadrantal. So you don't really have a quadrant for that, but we know that that is 90 degrees, which means it's a positive 1. Okay? But let's work more on those angles and things like that. So let's talk about this one, and then I'm going to give you one to try on your own. So here, this is telling you what the double angle is. Okay? The double angle answer to this is 4 over 5. Over here, this is talking to you about what the regular angle is. Okay? So this information is for the sine. All right? This is going to help us tell the sine. All right. So this, if I'm at pi over 2 to pi, that means I'm in quadrant 2. So now you know, in the end, the sign for cosine x has to be based off of quadrant 2. Okay? All right. Now, let's start figuring this out. Think about your formulas you have. Okay? I believe it's a double angle. Yeah. And see if there's a formula up here that can help you figure out what cosine is. Hopefully you found it. It's this one right here. And all you need to do is apply the formula and solve for cosine. Okay? So we know that cosine 2a is equal to 2 times cosine squared a minus 1. Plug in and solve. Go. And then remember, your answer, the sign of it will be based off of whatever quadrant, whatever happens to cosine in quadrant 2. Okay. So we know that cosine 2a, 4 over 5, equal to 2 cosine squared a minus 1. My a is the same thing as x in there, okay? Yes, well, I mean, we could kind of, no, never mind, just kidding. I was going to say we can kind of figure out what a is, but that's not what's going on. All right, so how do I get this cosine by itself? Well, we're going to add 1. So you just go to your handy dandy calculator, 1 plus 4 over 5. I'm not going to show this stuff because you know how to do the calculator. And that gives you 9 fifths equal to 2 cosine squared a. Okay. So now we're going to divide by 2. So just go to your calculator, take that answer and divide it by 2, and you get 9 over 10 equal to cosine squared a. Now, we know that we are in quadrant 2. Remember, all students take calculus. In quadrant 2, it's all about the s, which is sine and cosecant being positive. So that means in quadrant 2, this answer has to be negative. So we know that when we take our square root down here, because how do you get rid of something squared? You take a square root. We are going to be looking at the negative version of this. So we don't need the plus and minus. We already know that it should be the minus version. So cosine x is going to be equal to the negative version. And then remember, I told you that whenever you have a fraction under a radical, you can separate it. The square root of 9 over the square root of 10. Okay? So from here, we know that the square root of 9 is 3. Oh, sorry. The negative stays. Negative. Square root of 9 is 3. Square root of 10 does not break down, but we cannot have radicals in the denominator, so you have to rationalize. So in the end, we now know that cosine x is negative 3 square root of 10 all over 10. And there you go. Negative 3 square roots of 10 all over 10. Yay! Okay, so when you're dealing with these problems, you got to think a little bit more, especially when they give you this interval. Okay, so you're still applying formulas, but now you got to think a little bit more. Watch the signs. That's the tricky part on this. Try this one. Oh, sorry. I know I've got another one. Too many skips. Really? Oh, I skipped over it. Try this one on your own and go. Okay. So, just making sure I didn't skip over anything else. Again, this is about the sign of alpha. So over here, we know that we are in quadrant 1 because we're between 0 and 90 degrees. That's quadrant 1. And so we know that in quadrant 1, everybody's positive. But down here, we're dealing with the half angle of alpha. So we need to know what quadrant is this in. We didn't have to worry about that over here because this matches the angle we were dealing with here. But when you look at this one, alpha does not match the half angle. So we need to take this and we need to cut it in half because we need to know what quadrant is the half angle of alpha in. So 0 divided by 2 is still 0. Pi over 2 divided by 2 is pi over 4. And now you have the interval that tells us the sign of our function. Okay? We didn't worry about that here because these two intervals already matched each other. This was about x and this was about x. But when you look at this, this is about the half angle of alpha, and the original guy up here was just about alpha. So again, that's why I said you got to be careful because this is the interval that's going to tell us the quadrant for our sign. And 0 to pi over 4 is in quadrant 1. So now you know that this answer has to be positive because cosine in quadrant 1 is positive. And so now all you're going to do is use your formula, okay? Find a cosine half angle formula that we can plug 1/5 into and solve. And go. Okay. So we're just going to come down here. Let's go in here. We got cosine half angle. There's only one. And we don't have to worry about the plus or minus because we know it's going to be positive because we're in quadrant 1. So we just need to take 1 plus cosine A divided by 2 and the square root of that. So we're going to have the square root. Oops, sorry, that's where my answer is going to go. So we know that cosine alpha over 2 is equal to the square root of 1 plus cosine alpha all over 2. So we plug in 1 plus cosine alpha, they told us it's 1/5. So 1/5 all over 2. All right, 1 plus 1/5 is 6/5. So we have 6/5 divided by 2. So divide by 2. And we get the square root of 3/5. Sorry, I should make my square root bigger. Let's get the fraction in there. And again, this is just fraction work I did on my calculator. It's a horrible radical. Man, it's lagging today. There we go. And remember, you're going to have to rationalize this and separate this. As we just talked about, a radical or a fraction under the radical needs to be separated. So what we're really working with is the square root of 3 all over the square root of 5. None of these break down, but you do rationalize. And that gives us the square root of 15 on top all over 5. And again, we already know that that's positive. So that's the answer. Square root of 15 over 5. Boom goes the dynamite. All right. So I think these are the ones that are the trickiest in your homework. Just be careful of them. It's really the signs that throw you off. I mean, you guys are great at running the equations, but you got to think about the signs. All right. So they want you to express this as a single trig function. So they're just having you work backwards here. Give it a shot and go. Okay, so 1 plus cosine 86 all over 2. So 1 plus cosine all over 2. That looks like right here. So they want you to take this 86 and plug it back into the half angle formula. So this guy right here is equal to the cosine half angle. So go ahead and plug in and tell me what the answer is. So all you had to do was take cosine of 86 divided by 2. And cosine of 86 divided by 2. Oops, let's get an actual color here. Okay, come on now. Gives you cosine of 43 degrees. That's it. That's all they wanted. Just take it backwards. And then last but not least, and every section had one of these, so here it is. Here's the verify. Take this side over here, tangent 9x plus cotangent 9x, and make it look like 2 cosecant 18x. And give it a shot and go. Okay, so the easiest thing I'm going to tell you is to turn these into sines and cosines. And again, since this is a verify, it's going to be multiple choice, and the multiple choice is going to have the workout down below. Just make sure that that work, whatever you choose, matches the work that you do. Again, the easiest thing is turn these into sines and cosines. So tangent is sine 9x over cosine 9x. Cotangent is cosine 9x over sine 9x. So the next thing you want to do is put these fractions together. So you need that common denominator, which is going to be cosine 9x sine 9x plus cosine 9x sine 9x. And then we're going to put those together. We'll get the numerator here in just a second. Oops, no plus on the bottom. Okay. So here's what I have. Here's what I need. So cosine 9x, it's missing the sine 9x. So this guy's just going to get multiplied by sine 9x. Sine 9x. So sine 9x times sine 9x, that is sine squared 9x. It doesn't give you 81x squared, it's sine squared. Okay? This guy has sine 9x, it's missing the cosine 9x. So this guy's going to get multiplied by cosine 9x cosine 9x, which gives us cosine squared 9x. So on top we have sine squared 9x plus cosine squared 9x. Now that looks familiar. Sine squared plus cosine squared. We talked about that earlier. This is just the number 1. So what we have now is 1 over cosine 9x sine 9x. Now, remember, this 9 turns into an 18, which means that this is acting like a double angle formula. So we need a double angle formula that we can use to multiply the 9 by 2. So cosine and sine. Well, that looks like sine double angle. And if you think about this, that means I'm going to have a sine double angle on the bottom, and 1 over sine, oh, is cosecant. So things are going to work out. Okay? So let's take a look at what's going on. So if I look at this, it says I need a 2 sine A cosine A. Okay? So I need this to turn into a 2 cosine 9x sine 9x. Okay? Because I will change that into sine 2 times 9x. And that will give me sine 18x. Now, the thing is, I don't have a 2 here. So what can we do? Well, remember we did this earlier back on problem number 4 right here. Remember how we forced that 2 in the top to make it happen? And then we just multiplied it by 1/2. So this is like multiplying by 1. That's exactly what's going on here. So if I want to force this 2 down here in the bottom, that means I need to take this numerator and also multiply it by 2. Because 2 over 2 is 1. So that gives me 2 times 1 is 2. And that is 2. But look at this. Oh, I need that 2 in the numerator. And then cosecant 18x. Well, anytime you have sine in the denominator, sine in the denominator means you have cosecant. So that 2 multiplying by 1 up here helped us get exactly what we needed. This put the 2 in the numerator, and then this gave me the double angle of sine in the denominator, which is the reciprocal of cosecant. And there it is verified. Okay? Don't forget multiplying by 1. Multiplying by 1 is a pretty big deal for us. Okay? And that is section 10.3. Yay!